This movie is for learning target 8 and 9, writing equations in point-slope form. Point-slope form is a non-vertical line that passes through a point, x1, y1, with a slope of m. This is the equation that we're going to use. So we're going to take the point that we have and the slope and put it in this form, where it's y minus y1 from the point equals our slope times x minus x1 from the point. It's interesting that we only need a point and a slope to put it in point-slope form. Very creative name. You use this form to go from a point and a slope to an equation of a line. This equation is sometimes what I consider maybe an ugly equation because we're used to y equals mx plus b, slope-intercept form. But this allows us to get an equation nonetheless, and we could change it to slope-intercept form from this equation. So we need two things, a point and a slope. And we just plug in the point and plug in the slope. Keep in mind that y and x are our two variables that we need for the equation of a line. Here's our key concept. This is from your quick notes, and you'll see the point-slope form again. We have standard form, slope-intercept form, and now point-slope form. Again, point-slope form is a brilliant form that allows us to go from a point and a slope to at least getting an equation for the line. Identify the point and slope from this equation and then graph. So here we have an equation, y plus 3 equals negative 2 times x minus 1. What I'm going to do is I'm going to first write my point-slope form right underneath it. So y plus 3 is y minus my y1. M, you can see right here, is obviously negative 2 because those match up. But the problem over here is that there is a negative in my formula, but I have a positive here. So we'll have to remedy that. X minus x1 leaves us with x1 being 1. So let's see what we do over here with the y's. I can take y minus y1 and make it y minus negative 3. That way I've got the minus from my equation right here. This would simplify to y plus 3, so it works. It just means that my y1 is negative 3 rather than a positive 3. So please keep in mind, if you have y plus 3 or plus anything in your equation, it's going to have to be a negative number. Now over here we've got our slope is negative 2. And we have the x1, because the negative is here in the equation, I have x1 is 1. So our point is 1, negative 3, and the slope is negative 2. That's how you extract the point and the slope from our point-slope form. So we first plot this point, 1, negative 3. Then we use the slope of down 2 to the right 1, down 2 to the right 1 to get more points. That's how you graph your line. So given an equation that's in point-slope form, extract out your point, extract out your slope, plot the point, and use your slope to get more points on the graph. Try this one on your own, so pause the movie and then press play when you're ready to go over it. Okay, now that you've tried this, again, what I like to do is write the equation right underneath. Y minus y1 equals m times x minus x1. Because this negative right here is also in the equation, I don't have to change the value of 2. My y1 is 2. I have a negative in my equation, but I have a positive here. So I have to rewrite this one as negative 1 or minus negative 1. So over here I have y minus 2 equals, my slope is obviously 1/3, times x minus negative 1. So that tells me that my point is negative 1, 2, and my slope is 1/3. So I plot my point negative 1, 2 right here. And I use my slope of 1/3, up 1 to the right 3, to get more ordered pairs. And that's how you graph your line. Let's try another. Here we've got a point and a slope, and we're going to write the equation in point-slope form. So again, I write my point-slope form underneath. Y minus y1 equals m times x minus x1. Now I'm plugging this in, this one for x1, and this one for y1. And this is obviously my slope. So I plug 2 in for y1, and I plug 4 in for x1. So I get y minus 2 equals negative 5/3 times x minus 4. And that's your equation in point-slope form. Go ahead and pause the movie, try this one on your own, and press play when you're finished. All right, let's see how you did. So again, I put my point-slope form underneath. Y minus y1 equals m times x minus x1. Now I'm plugging in 1 for my x1 and negative 8 for my y1. And 1 goes in for the x1. And obviously, negative 1/5 is my slope, so it goes in for m. So I get y minus negative 8. Now that simplifies, so I'm going to rewrite that as y plus 8 equals negative 1/5 times x minus 1. And that's your equation in point-slope form. Now, as you can imagine, we could subtract 8 from both sides, distribute in this negative 1/5, and put this equation in slope-intercept form very easily. So what we're going to do here is write an equation in slope-intercept form that goes through each point. Sometimes slope-intercept form has crazy y-intercepts. And when that happens, sometimes it's best to go to point-slope form first and then convert to slope-intercept. So there's two things we need for point-slope form. We need a slope and a point. Well, we've got 2 points. The first thing we want to do is find the slope. So we do change in y over change in x. We get 2 over 2. My slope is 1. Now I've decided to use the point 1, 2. That tells me to put 1 in for my x1 and 2 in for my y1. So again, I've got my point-slope form. And I'm plugging 1 in for x1. I'm plugging in my slope of 1. And I'm going to plug 2 in for my y1. So I get the equation y minus 2 equals 1 times x minus 1. I'm going to distribute in that 1, which doesn't change anything. And then I'm going to add 2 to both sides. That gives me slope-intercept form of y equals x plus 1. So first you get it in point-slope form, and then distribute in, add this value, and you get slope-intercept form. Pause the movie, try this one on your own, and then press play when you are finished. Okay, let's see how you did. First you find the slope, which should be negative 6 over 5. And I used the point for negative 2. Does it matter? No. Could you use x or 9 and negative 8? Absolutely. So I plug that in my y minus y1 equals my slope times x minus my x1. Here I'm going to distribute in negative 6/5, and here I'm going to make this plus 2. So I get y plus 2, and I distributed the negative 6/5 in. Then I'm going to subtract 2 on both sides. I change this to a mixed number. 4 4/5 minus 2 is 2 4/5. So I get my slope-intercept form. How did you do? Hopefully very well. What is an equation for this line? Well, if you notice, the one thing about this line that you might not like is that you can't see what the y-intercept is. You could guess, but guessing is not a good method. It does look like about a half, but we're not certain that it is. So another method to do is to get 2 points on the graph, find your slope, and your slope is up 2 to the right 5, and take one of the points, like 1/5, and so we've got our slope of positive 2/5, and our point of 1, 5, and we plug that in, 2/5, 1, 5, we get y minus our y1 equals our slope times x minus our x1. It gives us an equation. It's in point-slope form, but it's still an equation. Now, if you want it in slope-intercept form, you could distribute this in and then add 5 to both sides. But it just says an equation. So this will do. Point-slope form for this line. Could you use the other point? Absolutely. Would it look different? It absolutely would. But would it be equivalent? It absolutely would. Okay, pause the movie, write an equation for this line, and then press play when you're finished. Okay, so you probably noticed here, this is not an exact y-intercept. So y equals mx plus b is not going to work for us. Instead, identify your slope and a point. I chose to use this point, and my slope was down 2 to the right 5. So I have this slope and this point. I'm going to use point-slope form. So I plug it in, y minus 1 equals negative 2/5 times x minus 2. And that's it. Again, it says an equation for the line. Is the relationship linear? If so, write the equation in slope-intercept form. So here we could find if it's linear by doing our change in y's and our change in x's. And then we would take our change in y and put it over our change in x. And then take this change in y and put it over this change in x. So when I do negative 12 divided by 6, I get negative 2. Negative 6 divided by 3 gives me negative 2. And then 8, negative 8, divided by a positive 4 also gives me negative 2. So it's a constant rate of change, so this is a linear relationship. Now I do not have 0 for my x in any place, so finding the value of my y-intercept seems difficult. What I'm going to do is I'm going to take my slope that I now know, negative 2, and I'm going to extract one of the points. I'm going to take 2, negative 3. I'm going to put this in point-slope form. Y minus negative 3 equals negative 2 times x minus 2. By doing that, I get an equation. Now I'm going to change that equation to slope-intercept form. So this gives me plus 3, and I distribute the negative 2 in. Then I subtract 3 on both sides, and I get y is negative 2x plus 1. There's my slope-intercept form. So you find your rate of change, your slope, pick one of the points, put it in point-slope form, and then convert to slope-intercept form. Try that with this. Pause the movie, try it on your own, press play when you are finished. All right, so we find the rate of change, the slope, and you should get negative 2.5. If you leave it as a fraction, that's fine as well. And then you choose a point. I decided to choose the first one, 10 and 640. And I'm going to plug that into my point-slope form. So it's y minus 640 equals negative 2.5 times x minus 10. I distribute in, simplify, solve, and I get my slope-intercept form. Y equals negative 2.5x plus 665. So the slope of negative 2.5 represents the rate of descent of the balloon in meters per second. The y-intercept of 665 represents the initial altitude of the balloon in meters. So point-slope form is very convenient. Given a point and a slope, you can put it then in slope-intercept form, and that helps you identify the y-intercept. Pause the movie, try this one on your own, press play when you are finished. Okay, volume of water in a tank. First thing you do is find the slope, which is 1,250. Then extract one of the points, I chose the first one to use, and put it in point-slope form. Y minus 3,320 equals 1,250 times x minus 2. And then it asks for what the slope means. The slope of 1,250 shows the amount of water increasing at a rate of 1,250 gallons every hour. And that is how we use point-slope form. I'm not going to do this one, but feel free to use this as an extra example if you'd like. And that's all for this movie.